welcome to Todd Talk number 5. Here's our date, in case anybody doesn't know. I did want to call your attention, our topic is affordable earthquake retrofits. I'm supposed to drop the dog. Just want to call attention to our next Todd Talk, which please put on your schedule. It's going to be on ADUs again. And we're going to look at the difference between using a modular factory-built building versus a custom site-built building. So tune in for that. April 25th, same time, 11 a.m. Okay, so here we are, our subject, affordable earthquake retrofits. Let's talk about what this means. What is a retrofit? A retrofit is taking something that was built one way and changing it for whatever reason you need. In this case, we're talking about the fact that many older buildings are not built to withstand medium to larger earthquakes. Affordable, we all know what that means, basically within your budget. So I have construction experience. I trained with a master carpenter 40 years ago. So I know construction very well. And one of the things that when you're looking at residential construction, especially in the Berkeley, Oakland area, the Bay Area, the older cities which have a lot of older building housing stock, is that you are going to see a majority of them are not ready for an earthquake. So what I wanted to do, this is really sort of a community service. We are not structural engineers. So these are sort of, I wanted to educate y'all, homeowners and architects, on the concepts involved around this. And then you can make your choices based on your budget and what your situation is. So I wanted to do basically doing some teaching, some understanding, and my staff is here with me, and they'll be learning as well. So I have up here the idea of concepts. So we'll go through all these concepts, and hopefully at the end you'll have much better understanding of related to earthquake preparedness at your home. I do want to give you a caveat that the idea here is that you are, when you're upgrading a house, an existing residence, these are what's called voluntary upgrades. You are not required by municipalities unless maybe you have a brick home or something and you get a letter to do any seismic upgrades to your house. So these are all voluntary. So that means you are not required to get a building permit to do these. Or a structural engineer, hire a structural engineer. There are many firms in the Bay Area that do these kinds of things with and without permits, with structural engineers, without structural engineers. So a wide variety of people are doing seismic retrofits. So after you understand these concepts, I think you'll be able to make better choices for yourself, given your situation and your budget. We're going to talk about seismic loads. So seismic loads, or what we call lateral loads, are not, when we talk about loads, we're talking about weight. That are not gravity loads pushing down. They are sideways loads, or lateral loads, because as the earth shakes, you can see this is fine on the earth. There's no more real load, gravity load. What's happening is the building is getting torqued in this kind of direction. So seismic load is important to understand. So if you have a single-story residence, you have in a wood residence, your seismic loads are very low. In other words, the amount of work that your building has to do to hold itself in place, if you think about it, the amount of resistance that your building has to have in order to resist an earthquake, damage from the earthquake, is very low. Because although the building is somewhat heavy, it's low to the ground. So this is a single-story house, there's a second-story house. This is a weight, this is W equals weight. Which of these two has a greater seismic load? Well, it's the one higher up, right? If you shift this, right, the one higher up is this what's called a moment arm in structural engineering. It's going to really have to work hard at the base to resist a load this high up in the air. So single-story homes, and so the first thing to think about for your condition is whether you have a single-story or a two-story home. We are only going to be talking about single-story homes today. Two-story home seismic requirement, seismic retrofit requires a structural engineer. It is a much different conversation. So I'm just going to defer you right to an engineer. And a single-story home is something you can do a little work to, not expensive, an inexpensive amount of work to it, which will create a great result in upgrading and preparing your house for an earthquake. One, of course, caveat is earthquakes come in all different magnitudes depending on where you are vis-a-vis vis-a-vis a fault line, and strengths, and all kinds of, and they're very chaotic events. There's no guarantee, even if you bring your house to full code compliance, that your house won't be severely damaged in a major earthquake. So what I'm trying to impart is do some minimal, some let's say affordable things, not costly, to make quite a big difference in the ability of your single-story structure to withstand an earthquake. So we know a seismic load is pretty low on a wood frame building. It's higher on a single story, it's higher on a second story, third story it's higher. If you introduce other materials that are heavier than wood, this weight gets larger, right? Puts more force on the building to resist it. So when you see a tall concrete structure built in California, incredibly heavy, very tall, incredible seismic loads. It needs a massive, massive foundations in strength to withhold the forces of an earthquake pushing the ground back and forth as this massively heavy building tries to resist that. Wood frame building made out of light wood, very, very strong material that's very light. So, so we talk about seismic loads, tension versus compression. So one of the things people don't understand about earthquake is that it's really not going to hurt your building in what's called compression. What it's doing is, and this is an important conversation. If I'm an earthquake and I have a little friction here, this is called overturning or uplift here. So the building wants to basically lift off. When the force is this way, it wants to lift off in this direction, and of course the force is also going to be in this direction. So one of the most important things to understand is this is not our issue. This is our issue. This is our issue, uplift. And resisting uplift is probably the biggest thing that the old houses don't do. They have a sill on a concrete foundation, and they build this wonderful wood frame building, but they don't really tie the building, the wood structure down to the concrete foundation. And often people hear about that. Well, you need to bolt the building to your foundation, and we'll get to what that is. So we need to resist uplift. It's very easy to do this. This is not difficult. Nor is this necessarily expensive. So that's why the talk is called affordable. So they really drill home that bolting into an existing foundation is really simple to do, easy to do. So we talked about lateral versus gravity loads. We're going to talk about older homes, and the introduction of Portland cement. So Portland cement is the strong stuff. It was introduced in about mid-1920s. This is obviously a little cut through your house, right at the lowest part. This is what's called a concrete foundation or footing. Most of the concrete done before 1925 is what's called pre-Portland cement. It is not very strong. After 1920, they introduced in the mid-20s, Portland cement was introduced much, much stronger. So you can tell that if you want to go into your house and take a hammer to, you should not be able to chip concrete off easily at all when it's Portland cement. This stuff is really, really strong. So if you can take a hammer to your, then you want to think about getting a structural engineer involved and replacing your foundation. For the most part, foundation replacement is expensive and mostly not needed for a single-story home. Okay, there's not again, these are light homes, incredibly strong, and tensile strength. So what's going to happen? Most older homes are built. There's a ground level, there's a concrete footing, foundation that's put around it, and then this little wall is built. And then what's between the dirt and our first floor is what we call a crawl space. Most of us are familiar with this, right? It's 2 feet, 18 inches, 2 feet. You can crawl in it, and that's why you have all these older homes with little stairs up, 2 or 3 stairs up to get to the. We have one, 2 or 3 stairs up to get to the first floor, right? And this is all made out of wood. This is what's called a cripple wall. So the cripple wall is where we're going to be doing. We're going to be doing when we do an affordable seismic retrofit. We're working in the crawl space. That's where we're going to be working in. We're working when you open the door to get into the crawl space, and you look in there and you see little 2x4 studs, and you see the foundation, and you see the existing sill. We're going to be working in that space. Okay. So here are the things. So we talked about Portland cement and foundations. So I'm going to jump to. This is. Let's look over this over to here. So we have This is a schematic, just a simple drawing of a plan, a foundation plan, and where you're going to get the biggest bang for your buck, assuming we're talking about trying to be affordable here, is strengthening the corners of the building. Right? That stands to reason. The corners are where, if you tie a tent down, if this is a tent, I wouldn't have a tie here, right? I have a tie here at the corners. All tents tie right at the corners, and then they expand out into the corners. That's where you're getting most of your load, right? It's where it needs to be pulled down. So the first thing we're going to do is, here's a little diagram of what I recommend as your first step in doing a seismic upgrade to your single-story home, wood home, that has a cripple wall. If you're talking about a home that sits on a slab on grade, that you're going to need to call an engineer or an architect or a seismic company. This stuff that I'm talking about here, you can do on your own if you're handy, if you're skilled. So this is the drawing, a large drawing of a corner of an older home. It has got you're looking down at the plan, and you see what I'm suggesting adding 4 of these 1/2-inch threaded steel rod in a 5/8 inch hole, a minimum of 6 inch deep. And you're going to epoxy. You're going to put epoxy in there. The really important things are, this should be this should be every 4 feet if you're going to do the whole house, but you don't need to do the whole house. So a key resource, if you're in the East Bay, in Berkeley or Oakland, El Cerrito, Richmond areas, is that Berkeley has a tool lending library. So it is on MLK in Russell, I believe. It is an incredible resource for doing this. So they have information on how to do it. They have the tools on how to do it. I believe they even sell the epoxy and the materials. So don't forget that if you're going to do this yourself, go to a resource like the Tool Lending Library in Berkeley. And there's also obviously lots of stuff online. So we have a couple of things we're going to do to strengthen these corners. We're going to add our 1/2-inch steel rod a minimum of 6 inches deep. We're going to drill a 5/8 inch hole so that we have enough space in there to put our epoxy. One key thing is that once you've drilled this with a very simple, you have to drill this. You have to drill a hole first into the wood with a wood bit. Then you're going to get into what's called a masonry bit. And all of this is really easy to do. The masonry bit you're going to drill has an impact. This will drill this really quickly. Lots of dust will come out. You need to vacuum out or blow out all of that dust. Because if you have a bunch of dust in there, your epoxy isn't going to hold, right? So it's got to be clean. Really, you can also clean that out with water. So this is a really straightforward thing to do. You can buy all this stuff at Home Depot. So once you've done your bolting, you're bolted down, you're then going to add plywood. The plywood is going to stiffen these corners up. And it's also going to tie this flooring system, it's going to tie it down to here. So remember uplift, we talked about uplift? Plywood is incredibly strong in tension. Incredibly strong in tension. So as this building in the corner and an earthquake is going to want to pull up, pull out, shift around, we've tied it down and then we've used plywood to stiffen it and to tie this floor to this footing, to the ground. So now we've really strengthened the building. We do it in all the exterior corners, and you've got basically an affordable seismic improvement. So let's see, just a couple other things to talk about. We talked about cripple walls, that's this. Structural engineers. It's always great to have a structural engineer. Structural engineers cost money, people are worried about that. You can have them advise you on things. You can call our office for advice. It's always good to have professional advice. If you're dealing with trying to get something done for $2,000 to $3,000, you can go this route, have a local handy person do it. Probably going to be around $3,000 or so, depending on the size of the house. This is maybe 800 square foot house. So let's see, what have I not talked about? I talked about tooling libraries, do it yourself, right? Stiffness in the corners. Soft stories is just a concept. If you do have a 2-story house, and you do have, or even if it's a 1-story house, like a garage, and you have a big opening, you have very little wall. You have what's called a soft story. Anything like this where you have very little wall, you have a lot of opening, or if it's a more contemporary house, that's going to require structural engineering. So this is simply for the older houses, the single-story older houses that really, when you talk about when they're built between, say, 1920 and 1960 or 1950 or 1960, before the introduction of tying buildings to foundations with steel anchor bolts. Questions?
I was wondering, does the entire house require retrofitting? I know you mentioned about just those corners, which is like the bare minimum we could do. But how about the walls, especially if you're going one floor higher? Is there anything?
Yeah, so the question was, does the entire house need retrofitting? On a single-story house built between let's just say 1920 and 1980 or 1960, there's a lot of, in our area, there's a lot of houses, right? So that need retrofitting. You're not going to need to do more than this. The houses are so. In the 1920s, 30s, 40s, 50s, the houses around here were built with old growth Douglas fir. And that's the strongest stuff on earth. It is so strong. Unless somebody's cut a big window opening or put a swimming pool or a parking garage on their house, there's just not the seismic load to resist. You're not. This will do plenty. Now, all bets are off on a 9.5 earthquake. Of course, you can always spend more, right? this is like, what I'm trying to communicate is this is affordable earthquake retrofits. That's what I'm communicating. Of course, you can voluntary upgrades. If you're more concerned about, if you want more information, to answer your question, you have to call a structural engineer. I'm just trying to do a community service. What I'm hoping is that people who might not do a seismic retrofit because they just can't afford it are introduced to these ideas and can think about it and do something.
Would you do anything different for a stucco house?
No, I'm assuming this house is stucco. Yeah, now, stucco is heavy, it's heavier, but the wood is so strong in a single-story house. There's a stucco actually, although it is heavy, and stucco is often added to wood, the outside of wood houses as a recladding. Stucco is also incredibly strong, and it comes with a wire mesh that is attached. So if you've ever tried to pull stucco off a building, you would know that it weighs, but it also strengthens and stiffens the building enormously. Question?
We have a question from a viewer.
Yes.
How can you tell if your house is bolted to the foundation?
Okay, that's a great question. So you'll go into the crawl space. There's a door underneath the crawl space, and you'll look at the sill plate that is sitting on top of the concrete. So it's a piece of wood, it's flat. That's the first piece of wood that's sitting directly on the concrete. Okay, that's called your sill. If it's bolted, you will see bolts. You'll see nuts and a bolt and a big washer. And you should see them about every 4 feet, at least right every 4 feet. They're visible.
Thank you.
If you've had a retrofit at all, you'll also see the plywood that's been added and screws. So you can easily see if your house has had some retrofit done. And what I always recommend is to homeowners is this simple: reinforce your corners, bolt down your corners, single story, and you're fine.
You mentioned it'd probably be a few $1,000s if you had a local handyman do it. How much do you anticipate the supplies would cost if you were to do it yourself?
Well, that's why I have 4 feet here, because a 4 by each sheet of plywood is about $25. So you need 1, 2, 3, 4, 5. That's $100. Right, 100 sheets. The bolts are maybe all the rest. So your materials are probably epoxy something, maybe $300. And your labor shouldn't be more than $1,000. So you could probably do it for $1,500 if you found the right people and you're really going to do it yourself. If you do it yourself, you do it for $300, $400. This is very easy stuff. If you're handy, you can do it by yourself. Any other questions?
I had a question.
Yes.
What if there are more steps in the house for the landing, for the ground floor landing?
Then say 3.
More than 3 steps?
Yeah, so it's very unusual.
Okay.
So, but if this was a good question.
Yeah.
If this is more
More
like
higher, yeah.
7 feet, you do see those houses, you should consult a structural engineer. Yeah. That's a great question, actually. This should be about 3 feet.
Mhm.
Yeah, great question. Okay? I hope you join us for our next, this is dear to my heart. This you'll learn a lot. When you're talking about, putting in your ADU, do you want, what are one of your options is to use a modular factory building, and then versus custom site build. So what are the advantages and disadvantages? So join us on April 25th for that talk. Thank you.
What is an ADU?
Accessory dwelling unit.
We have a question from a viewer.
Oh, we still have another question.
Yeah. Why were cripple walls even built as a part of the structure in the first place?
Why were
Why
cripple
were the
walls?
cripple walls?
Because it's a very inexpensive way to build. So all these homes were built out of wood. If you build your wood right on the, my staff can answer this question. What happens if you were to build your wood right up off the ground?
The moisture and the wood will start.
Yeah, your wood's going to be susceptible to moisture rot. So you want it big enough. Also, you want it tall enough so you can get underneath there for plumbing and heating and fixing it. So that's why homes were raised a couple of feet up into the air. Is that it?
Yep. Thank you.
Okay, thank you everybody.